On this 2010 to 2015 Honda Civic with the 1.8 gas engine, P0977 points to the CVT shift solenoid valve B electrical circuit reading high at the ECM/PCM. The car may have transmission drivability complaints, abnormal CVT operation, or it may only have a warning light and a stored code. Broadly, we're looking at possible power feed issues, wiring opens, the solenoid B circuit, the solenoid wire harness, or PCM-side control. One important point up front: this code is called out as an electrical circuit problem, not a mechanical failure inside the transmission. Before getting into pinpoint checks, start with the basic system checks and follow a structured diagnostic approach. Start by verifying the fault. Turn the ignition on, or use on mode if it has the engine start/stop button. Clear the code with the HDS. Start the engine in park and let it run for at least 10 seconds. Then check for pending or confirmed codes with the HDS. If P0977 comes right back, the failure is duplicated and you move into circuit testing. If it does not come back, treat it as intermittent for now. When captured data is available, reproduce the captured conditions instead of guessing. With the ignition OFF, check fuse no. B7, the 15 a fuse in the underdash fuse and relay box. If that fuse is okay, keep going down the diagnostic path. If it is not okay, replace the no. B7 15 a fuse. If it blows again, repair the short to ground on that fuse circuit before moving any farther. Next, check the IG1 Miss SOL line for an open. Jump the SCS line with the HDS. Disconnect PCM connector A, the 51-pin connector, then turn the ignition on. Measure voltage between PCM connector a terminal no. 1. The blue wire and body ground. You're looking for battery voltage on that feed. If battery voltage is present, the IG1 Miss SOL wire is okay, and the next step is the solenoid B side of the circuit. If battery voltage is missing, repair the open in the IG1 Miss SOL wire between the PCM and the no. B715, a fuse in the underdash fuse and relay box. Now test shift solenoid valve B. This is the point where you separate a solenoid side problem from the rest of the SOLB control path. If shift solenoid valve B works properly, continue to the SOLB wire continuity check. If shift solenoid valve B does not work properly, go to the resistance check at the solenoid itself. For the SOLB open wire check, turn the ignition OFF, jump the SCS line with the HDS, then disconnect the solenoid wire harness 8-pin connector on the engine wire harness side and PCM connector B, the 51-pin connector. Check continuity between solenoid wire harness connector terminal no. 4. The green with white wire and PCM connector B terminal no. 12. Also green with white. If there is continuity, the SOLB wire is okay. At that point, update the PCM if it does not have the latest software, or substitute a known good PCM and recheck. If P0977 goes away after an update, the troubleshooting is complete. If it goes away with the substitute PCM, replace the original PCM. If there is no continuity, repair the open in the SOLB wire between the solenoid wire harness and the PCM. If the solenoid operation check sent you to the solenoid itself, remove the solenoid wire harness and measure resistance between shift solenoid valve B 2-pin connector terminal no. 1 and terminal no. 2. The specification is 8, 9, 12, 2 ohms. If the resistance is in that range, shift solenoid valve B is okay and the directed repair is to replace the solenoid wire harness. If the resistance is not 8, 9, 12, 2 ohms, shift solenoid valve B is faulty, and the directed repair is to replace the valve body. After any repair, update, substitution, or harness work in this path, keep verification separate from the pinpoint testing. Clear the code, reproduce the operating conditions, and confirm P0977 stays gone. The key is not to treat this like a mechanical CVT fault. Prove the feed, prove the SOLB circuit, prove the solenoid measurement, and only then make the directed repair. For more diagnostic training, visit stepdiagnostics.com.